hang up and sign back on again. Probably get you on. Okay. We'll wait for you. And I think someone just joined. Oh, Jacob. Jacob.
Sorry, my internet was out.
All right, I'm marking you here. Then I marked you absent. Is Eric Jones here? All right. John, did you make it back? John made it back. So, hey, I found a cool thing. I guess there's a report that comes up on Google that can tell me this wasn't a problem for any of you guys in class, but I noticed like some people have been in class for like a few minutes and they just hang up and go away. And I missed it. It was under the radar. I feel like a sucker. But so anyway, loser teacher, loser her. Anyway, so what I'm going to do is like if you guys on the report, it only shows you've been on there for a few minutes. I will mark you absent even if you said you are here during roll. So make sure you stay during class. That's it. Okay, but there's no problems here with this class. No problemo. No problemo. That means no problem in Spanish. I'm teaching you guys across the curriculum. You guys Spanish. And me. John, did you make it? Jonathan?
Yeah, it just says camera is starting. I don't know why.
All right. Good luck, man. Thanks for trying. Okay. All right. Let's look at what we're doing today. Today is, and then tomorrow, I'm just going to try to review everything we've done. I feel like this chapter was a lot of stuff. It's a lot of stuff that actually is new to me. So I'm going to start reviewing all the stuff that we did, arithmetic sequence, geometric sequence. And today we're going to talk about finding the sum of infinite geometric sequences, okay? Finding the sum. So basically, we're doing page 387, 3 through 21 odd. 7.4, check your understanding today. Make sure you do your check your understanding. But basically what we're going to do is we're going to take the geometric sequence that are going to go, you know, we have term 1, term 2, term 3, term 4. We're going to go all the way up to infinity, and we're going to add all of those up. We're going to add them all up. Okay? So anyway, I'm going to get rid of this in 10 seconds if you haven't written the assignment down. Number 55, 7.4, finding the sums of an infinite series. Okay, I'm getting rid of this in 5, 4, 3, 2, 1. Okay. All right, here we go. Dink, 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 dink. All right, so let's talk about what we're going to do. Geometric series. Do you guys remember what that is? We talked about it yesterday. Not yesterday. We had a day off yesterday. Did anyone raise your hand if you had a great day off yesterday? It was nice not going to school for a day. Or at least not being on your computer, I guess, right? It was kind of nice. Kind of weird, though, that we're back. Now I have 2 more days. But tomorrow's Friday. Tomorrow won't be as crazy as the other days. I'll make it kind of easier. But let's talk about a geometric series. Remember that geometric series is equal to a to the, you don't have to write this down. This is Godzilla time if you have it. You got the first term times the ratio with the n to the minus 1, right? So we can have here, like, say I have geometric. Remember, now you don't have to write this down, but I'm going to do it. Okay, so let's say our first term is 1. Our second term is a half. Our third term is 1/4. Our fourth term is 1/8, and then 1/16, and then 1/32, 32nd, etc., etc., all the way up to infinity. Let's say we never stop. We go forever. Oh my gosh. Sensei wants to keep going. 1/64. I got a question, though, as I'm writing these, right? Gracie, are these numbers getting bigger or smaller?
Smaller.
They're getting smaller, like really small. like 1 out of 64, 1 out of 128, super duper small. So eventually they're gonna get so small, you're not even gonna be able to like add them up to each other, right? It's like you're not even, it's like you're adding nothing. They almost come to zero, almost to nothing. So we're gonna learn how to add these up using an equation, and knowing it's gonna come, it's gonna stop somewhere because it's gonna get so small, it's not even gonna matter how small it gets. Okay, it'll approach that number. It will never quite get to that number, but it'll approach that number. Now, this will work. This, I can see the sum of the sequence is, or this sequence is, my first term is 1. Can you tell my ratio is on this? You want to tell what it is? Yell it out if you know it. Otherwise, I'll show you what it is. What do you think the ratio is?
1/2.
1/2. Very good, Jay. Oh, by the way, Jay, your technique about finding a to the 1 yesterday, remember we had the 2 numbers? You were right. You just divide by a to that, what you were talking about from before yesterday. You were right. I was wrong. I don't know if you remember. Do you remember what we were talking about?
Yeah.
I just want to let you know that you are 100% correct. You could do it that way. I was thinking about the second class. Oh, yeah, Jay, I see what Jay's means. Anyway, we can go over that after class if you guys want to know what we're talking about. But anyway, so our summer series is, our series is 1 times the ratio 1/2 n minus 1, right? Anyway, you don't have to write this down, but you have to know. And by the way, I don't need the 1 here, but my first term is 1. My ratio is 1/2 n minus 1. Now to find the sum, it would look like this. The sum, remember we do the sum. If it goes to, remember we start with the first term, I equals 1. Can you guys see that down there? Let's see. Natalia, can you see this? Is this too low, or do I need my camera down?
I could see it.
Okay, great. So I start with 1.
We're
Now to
writing
go
it
to
down.
infinity, remember this is our last number. If we want to go to infinity, we put the infinity sign up there. That means it's going to infinity, right? And then we put our term 1 to the 1/2 to the n minus 1. By the way, I don't need the 1 there, so I'm just going to go like this. And this is trying to figure out the sum of all of these, right? This is what this is saying, is find the sum of the series 1 plus 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1/32 plus 1/64 plus 1/28 all the way up to infinity. Today we're going to have to figure out how to add all of those up. And I'll show you on this problem right here. Okay? To find the sum of these, you're just going to use this equation right here. Sum of the infinite series is the first term divided by 1 minus the ratio. Okay, so go ahead and write that down. This is Godzilla. Don't write this down. Even though we're doing Godzilla time, write this down. In fact, Godzilla time is over. We'll say Godzilla time is over. So instead of adding these up, we just plug it into this equation and boom, we're money. We got it. It's money time. Okay, Annika, what do I put for my a sub 1?
For which problem?
This whole thing here. This is all the same. This is this, and this is the sum of it. So we're adding them up.
1.
1. That's my first. A sub 1 is my first term. Annika's right. 1 over 1 minus. What do I put for my? So what do I put for my r? By the way, my first term is always right here, right? That's my first term. I just erase it, but that's the first term when you figure these out. What do I put for my r? What's a pirate's favorite letter? 'Tis the C. Okay, Isaac, I cannot see you, so I'm going to call on you a lot. Okay. What do I put for my R, Isaac?
Attention. What was the answer or question again?
Were you not paying attention? I'm sorry. Did I interrupt you, Isaac?
No, not really.
Oh, okay, that's cool. Isaac, what's the R? Isaac, why can't I not see you? Are you taking a nap because it's so cold here with the covers and just really sleeping and listening to the computer? It's okay if you are. Actually, it's not okay if you are. Don't tell me if you are. Isaac.
Yeah.
What happened? I'm asking you a question. Why did you hit the mute? We're talking. We're having a conversation. What if I started talking to you and then all of a sudden I hit my mute button and I went like this? Watch. It's rude.
My bad.
That's okay. I forgive you. Isaac, what's R?
Yeah.
Isaac, describe your setting to me. I can't understand what's going on. Are you sitting at a desk with a well-lit room?
Let me just reload real quick.
Wait. Isaac, don't reload. Where you go? Isaac, what is
Yes.
R? Can you see me?
Yeah.
What?
Yeah.
Okay, what's R?
I don't really know.
Okay. Reset. We'll get back to us, Isaac. You got to learn this stuff. Okay. Let's go with Gianna. What is R?
1/2.
1/2. Very good. Our R is what I'm multiplying by, right? It's this. R. It's our ratio. 1/2. Thank you, Gianna. So we say 1/2. So we take this whole series. If we add them up, it's equal to 1 over 1 minus 1/2, which is 1 over, what's 1 minus 1/2? 1/2, right? So you've add all these up. Guess what it's going to be? Go ahead and solve this. 1 divided by 1/2. What's my answer? 1 divided by 1/2. Let's see if you can get it. I'm going to call in one of you at random. Where's Isaac? Do you think Isaac came back? I'm going to look for Isaac while you guys are working on that. Am I in the way? Oh, Isaac came back. Let's see if this camera works. Isaac. Oh, there you are. What's up, Isaac? You look good. How you doing? Okay, so it looks like you have a good employee. I don't know. It looks like you're probably in your. I wonder if you're sitting on your bed or something. Are you at a desk, Isaac?
No.
You look like you're jammed in a corner over there. All right, Jose. What's our answer here? 1 divided by 1/2.
2.
Yes, it is 2. Does anyone need me to explain why it's 2? So if you took all of these and added them up, it's only going to add up to 2. That's it. Isn't that kind of funny? Does anyone need me to explain why 1 divided by 1/2 is equal to 2? Or are we good? Speak now or forever hold your peace. Okay, a key thing. This only works if my ratio is less than 1. If it's 1 or bigger, it will not work. Why? If my ratio is less than 1, it means these numbers are getting smaller. So they'll get so small that eventually they will add up to nothing. But if I'm gonna erase this. Well, maybe I can do it here. Let's say, I need another pen. Let's say, let me do a little separate thing here. Let's say I went 2 plus 4 plus 8 plus 16. It will not work here because my R is 2. I'm doubling it because it's going to get so big it won't work. It'll get to infinity. So it only works if they're getting smaller and smaller and smaller. Okay, let's get to work. Are there any questions before I erase all this? Remember, R has to be less than 1 in order for this to work. Has to be less than 1. John, are you still there?
Yeah.
All right, I'm going to erase this in 10 seconds. 5, 4, 3, 2, 1. Okay, remember Godzilla time is over. It's been over for a long time. Okay. So let's look at number, I think we start at 5 or 3. We start at 3. Okay, let's look at number 3. Okay. Let's look at number 3 together as a class, shall we? Looking at number 3. Oh, look, it's right there. It's all big. Okay. Let's read the instructions. In exercises 3 through 6, consider the infinite geometric series. Find and graph the partial sums, S of n. For n, you want to do the first 5 terms. 1, 2, 3, 4, 5. This saying, say n is the first 5 terms. Then describe what happens to n. So here's my term. So what is, I get the first term, then I add the second term, then I add the third term. What is the sum going to look like? Right? So the first point's going to be 1. The second point's going to be 1 plus 1/6. The third point's going to be 1. I'm sorry. The first point's going to be 1/2. The second point's going to be 1/2 plus 1/6. The third point's going to be 1/2 plus 1/6 plus 1/18. The fourth, right? Hopefully you get it. So here's number 3. What is this going to look like? We're going to graph it. So we have 1/2 plus 1/6 plus, you can see my ratio is 1/3. 1/18 plus 1/54 plus 1/162. Okay, now I think this will be a lot easier. I'm going to stop sharing so you can see what I have written here. I think this will be a lot easier if we write these as decimals. Okay, so 1/2 is 0.516, and we'll round them up because we just need a general idea. Is 0.16 plus 1/18, 1 divided by 1 divided by 18, 0.056 plus 1/54. Look how small these are getting. 0.019 plus 1/162 is 0.006, a very small number. So now we're asked to graph these. We're asked to graph the sum as we add each term up. Okay? So here, let's do a graph. You use your graph paper. I'm going to, unfortunately, my whiteboard is not graphically. It's okay, I only have one. So we're going to add, this is the first term. Now this is the first term plus the second term. This is first term plus the second term plus the third term. First term plus second term plus third term plus fourth term plus the fifth term plus the sixth term. This is the sum that we want to add them up to, okay? Now, let's go ahead and, so this is our n. Well, it's really n. Yeah, I guess we'll label that as n. Now, this is the sum of n's, where we add the n's up, right? Now, the number's not going to be that big, so we can actually write this as 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8. That's probably good enough. Now remember, we're finding the sum. I'll pause here so you can catch up with me. So let me, as you're doing that, I guess I'm going to do my sums over here so you can see. So this first one is just 0.5. Okay? Just the first term, 0.5, nothing to add to it. So where's my 0.5? Right about there. Do a point. Now my second one is going to be 0.5 plus 0.16. Okay? So 0.5 plus 0.16, that equals 0.66. 0.66, which will be about here. It'll be above the 6. So we get kind of big. And then the next one is 0.5 plus 0.6. So that'll be 0.66. That's adding them plus 0.056. So we're adding this one plus this one plus this one is my third point, right? You're just adding them up. So it's still on my calculator 0.66. So I add 0.056, which is 0.716. So adding all three goes up to just above 7. But see, notice it doesn't go up that high. Then this one plus this one plus this one plus this one. So 0.716 plus 0.019. See how that's a very small number. Plus 0.019. And that's 0.735. Notice it doesn't get that much bigger. 0.735. Notice it's just a 0.735. So that's going to be not much higher. And then 0.5, 0.16, 0.15, add them all up, which will be 0.735 plus 0.006. 0.741. See, it only increased by, and this didn't even increase a little bit more. So the fifth term will be right about here. And you can see it's going to flatten out. It's going to flatten out. So what this shows is it's going to approach 0.75. And the graph just shows that as we add, the numbers are going to be so small, it will not get past this 0.75 or somewhere around there. To me, it looks like it's about 0.75. And what that's showing is as we keep adding these, they get smaller and smaller and smaller. It's going to flatten out. That's number 3. We're going to say it approaches, let's write down, it approaches 0.75 is what it's going to approach. Are there 2 P's in approaches? I don't even remember. Approaches? Or is there 1? You guys are smart. Someone tell me. Approaches. I think there's 2 P's. I think it's right. Am I right?
Yeah.
You guys, is that easy? I don't know. That's why I don't teach English. Okay, so all of those you're just going to graph and add them up. So put them in, I think decimals would be easier to do. Okay, now I'm going to move on to 7. Are there any questions before I erase this? Okay, I'm going to erase this in 10 seconds. 5, 4, 3, 2, 1. Okay, it's gone. Look at number 7. Okay, so now we're going to get to the sum of geometric infinite series. We're going to start using this and just figuring out the sums. Now, sometimes they won't work, right? If r is bigger than 1, you just stop right there and say, hey, r is bigger than 1. There is no sum. We can't calculate it. You stop. Okay, number 7. Okay, we're given a series, I equals 1. So we start from 1. We go to infinity. We have a geometric series of a to the 1/5 times, or raised to the n minus 1 power. Now let's remember our geometric series is going to be geometric series is going to be a to the n equals a to the 1 times the ratio raised to the n minus 1. Now remember, first term ratio. First term ratio. So let's go ahead and plug this into our infinite series. 1 minus r. Okay, I want you guys to set up that equation there. So, okay, let me go. Okay, let's look at the question, actually. I should look at the question before I start writing it out. What's the question asking? Sorry, jump the gun. Jumping the gun. What's the question asking? Okay, number 7. In exercises 7 through 14, find the sum of the infinite geometric series if it exists. Okay? So does this one exist? What is r? Is it less than 1? Yeah. So it exists. If it's greater than 1, look at number 8. 3 over 2, that's greater than 1. It will not exist. Doesn't exist. Okay? But anyway, 7 does. That's what I have here. So I want you to go ahead and plug it in. And I'm going to ask you what this. So first plug it in. I'm going to ask you guys, I'm going to call on one of you to tell me how to plug that in. So go ahead and do that. Plug it in. All right, I'll give you 10 seconds to figure it out. 5, 4, 3, 2, 1. Okay, Madison, help me figure out, how do I set this up?
I put A1 equals 8.
Okay.
And then parentheses 1 over 5.
1. What is that? Can you see what that is?
Not really.
1. That's a minus sign. You can't see the minus sign?
Oh, yeah.
1 minus, what's my r?
1 over 5?
Yep. 1 minus 1 over 5. I think you missed the 1 minus that threw me off.
Oh, yeah.
Jay, did you type something? I saw something pop up. All right, good luck, man. Okay. So, go ahead and solve that, class. See if we can calculate that out. I'm going to call on one of you. Actually, you know what? Go into your groups. I'm going to have you go into groups. I want you guys to come up with an answer. Go. You're going into your groups. Come up with an answer. Go. There you go. Come up with an answer. There you go. What's the answer to that? Do it. Come up with an answer. Then I'm going to call on one of you. I'm going to give you... Who's this? Oh, Jay went to the bathroom. Okay, so we got 10. Most of you got 10. That's good. Hopefully you know how we got 10. 1 minus 1/5 is 4/5. 8 divided by 4/5 is 8 times 5/4, right? You multiply it by the reciprocal, and then this becomes 1, this becomes 2, and we get 10. So guess what that means? That means 8 plus the next plus this is all adds up to 10, right? 8 plus 8/5 plus 8/25. It's all going to add up to 10. Okay? That's it. So anyway, now let's look at 11. Okay, we're going to look at 11 here. I'm going to erase this in. Are there any questions? I think some of you are still joining, so maybe should I pause for a second? Are we good? Are there any questions on how we got 10? Okay, I'm going to erase this in 10 seconds. 5, 4, 3, 2, 1. Okay, let's look at 11. Only a couple more, then we'll be done. How are we doing on time? What time is it? 12:58. Been here for a little over half hour. Okay, 11. So we're given a sum. We're going to have 2 plus 6/4 plus 18/16 plus 54/64 plus ... all the way up. What is the sum of these if we go up to infinity? So remember, we got to figure out our R. R is A2 divided by A1, or 6/4 divided by 2. Or you can see that, I don't know if you can see that I'm multiplying these by 2/3. I can see it, right? No. 4 2/4? No, 3/4. Multiplying by 3/4. See if you can figure out what R is. 6/4 divided by 2. 6/4 times 1/2 is equal to 6/8, which reduces to 3/4. There's my R. R equals 3/4. What's my first term? Is there any question that? Ah, shoot, I erased that too fast. First term is 2. The sum of an infinite series, A1 over 1 minus R. See if you can calculate that out. Go for it. I'm going to ask for a full number. If you add all those up, what would it be? It's number 11. Okay. Should I break up into your groups, or you just want to give the answer? You guys want to talk to each other? I don't know. Let's see if anyone has the answer. Brandon, I can't see you, so I'm going to call on you. What'd you get?
8.
Yeah, it's 8. Any questions on how we got 8? So if you add all those up, it's going to add up to 8. So we have our first term, which is 2. 1 minus 3/4. 1 minus 3/4 is 1/4. So it's 2 divided by 1/4, which is really 2 times 4 over 1, which is 2 times 4, which is 8. All right. So that's that. I did like the easy ones. If you guys want to do harder, I mean, I could do more difficult ones after class, which some of you stay after class, no problem. Let's look at these. Let's look at these errors. real quick, and then we'll go on to the one more thing that I want to show you. But after I show you the errors, so you can understand, like a lot of times you have these errors right here. So let's look at what's wrong with this. It has this series, goes from 1 to infinity. Now, our first term is 1, right? If there's no number there, remember our first term is 1. So they put 1 there, that's right. And our r is 7 over 2. 1 minus 7 over 2, that's right. Negative 5 over 2, and negative 2/5. Can anyone figure out what is wrong with this? What they did wrong here? All right, I'm going to call on one of you since you're all so quiet. Who am I going to call on? Let's go with, you can't say I don't know. All right, let's go with Roberto. What's wrong with it?
7 over 2 is greater than 1.
Very good. Thank you, Roberto. Roberto is 100% correct. You can't, now I can't find my, there it is. Yes, it's bigger than 1. So you can't find the infinite series. So this is false. You cannot add these up and it'll go up to negative 2/5. No way, man. No way. No way. Impossible. So there you go. Okay. The last thing we're going to do. I keep sharing the screen. There we go. There we go. Okay, the last question that they're asking us to do that I'm going to work with you on will be number 19. Where's 19? Here we go. So write the repeating decimal as a fraction in simplest form. Right? You know this is 0.22222222222222222, right? It goes on forever. Repeating decimals. Well, the sum, this is actually a geometric series, 0.2222222222222. So I have here 0.22222. It's a series. Okay. Now I want to write, if I write, you know, if you write it as a fraction, you can make it a fraction. Well, how do I write this as a fraction? Okay. Well, let's write it as a series. I know you can't see it as a series, but let's make this an addition problem. The first term, let's say, is like, okay, what, let's go with Taylor. What number do you see here? This like a number that you see. Like, I don't know how to ask it. So it's kind of weird if you don't get it right. It's my question. What's the first number you see when you see this that you think?
2.
2. Thank you so much. So our series is going to be with 2. Now, it's not the whole 2. The first 2 is 0.2. That's the number that we see. But it's not just that. I want to add this 2 to it, which is 0.2. Right? That's 2. Then I want to add this 2 to it. 0.002, right? And then add this 2, 0.002, right? If I add all those up, and then 0.000, right? That's, if I was to break this up and add them up, it looks something like that. That's my geometric series. It goes up to infinity, however much that is. And I'm going to write that as a fraction. So let's go with an easy question. Alex, I can't see you. I know your camera's messed up. So Alex Garcia, what is my first term? Alex, I'm going to mark you absent if I don't hear from you. Okay. Alex, I am marking you absent because I don't know if you're here or not. If you are, come after class. I'll leave you a nice little message here. Alex Garcia, are you here? If not, I am marking you absent. Okay. Alex Garcia, I'm marking you absent. All right, here we go. Let me hang on. I gotta change my role real quick. Okay. Boop. If anyone's friends with Alex, let him know that I marked him absent. Okay. All right. What was my question? Oh, what's my first term? Let's see. Ethan. Oh, let's go. Brandon. I can't see you, so I'm calling Brandon. Brandon, what's my first term here?
0.2.
Why do you keep turning off your camera, man?
Because I have family coming in and out of my room.
Oh, they're fine. It's fine. I have students where kids are just like playing around in the background. Don't even worry about it, man. Don't even worry about it. Okay. All right. 0.2. Okay. 1 minus Alex Garcia. Okay, Alex is not here. Jose, what'd you get? 1 minus what? Oh, what's our R? I got to figure out the R, right? Jose, how do we figure out the R? R, the ratio. How do we figure that out?
That's one step I'm not quite sure. If you could tell me how to get the R after class.
After class, I'm going to tell you right now, or someone will tell you. Donnell, how do you find the R?
I don't know.
You know who's going to tell us is Alex Garcia. Alex Garcia, how do you find the R? Okay. Matthew Gonzalez, how do you find the R?
I don't know.
Alex Garcia, I marked you absent. See me after class.
I was pooping.
Prove it.
Oh, no.
No. Okay. See me after class, Alex Garcia. Okay. Let's see. Who is that? Matthew Gonzalez. How do I figure out the R?
I have no idea.
What's that?
I have no idea.
No one knows. Have I taught you? Have I shown you how to do this?
It's A2 divided by A1.
Yes. Thank you. Gracie, we go. It's, dude, Jose. It's this divided by that. Jose?
I had no idea.
Well, I don't blame you. I blame the teacher. Okay, so it's this term divided by that term, or 0.02 divided by 0.2. Okay. So, Carlos, what is it? What's 0.02 divided by 0.2?
0.1.
0.1 is my R. R equals 0.1. So I have here 0.1. Now remember, we want to write this repeating decimal as a fraction, for all that distraction that we had. So 0.2. Now what is 1 minus 0.1? 0.9. And write this as a fraction. It is 2/9. And that's all you got to do. Make sure you know how to solve for the R. We talked about that yesterday. We talked about it today. And I get it. I get it. I get it. You know, we're just like, it's easy to tune out. It's easy to tune out in the class. Sometimes we have to poop. I get it. I do that too. I hate to admit, I mean, I'm a person too. But you got to try your best to pay attention. All right.
What number was this one?
What number was that? That was 19. 19. Let's see. Is Isaac there? There you are. Okay. Alex Garcia, are you still there?
Yeah.
How come you're like, is it like your camera's weird, or are you just not like, move your camera around for me? You moved your hand. Oh, you look like a ghost. Is this ghost mode? You get a better graphics.
There's like water in my camera or something, I'm gonna be honest.
Yeah, it's weird. Is that a school one?
No.
All right. That's pretty much it that we have. If you want me to do other problems, you could stay after class. with me and Alex. I'm going to quick talk with Alex. And are there any questions before I dismiss you? It's not sad, Jose. It's just, I don't know. Alex, you feel sad?
Sensei, can you move a little bit so I can see the board?
Yes.
Thank you.
Alex, do you feel sad?
Why?
Oh, because Jose said it sounds like you have water in your microphone and your camera, and he felt sad for you. You felt bad. But
No,
I don't
okay,
think.
I'm good.
Okay. All right, guys, you can go. I'll see you tomorrow. Bye, Kayla. Bye, Gracie.
Bye,
Bye,
Sensei.
Brandon. Bye, Jacob. Bye. Bye, Taylor. Bye, Gianna. Bye, Josh. Bye, Jaylene. Ethan. Annika. Isaac. Roberto. Jose. Ishi. Jasmine. Giovanna. Morella. Jay. Carlos. John. Natalia. Matthew. Okay. Is Alex still here? All right, Alex. So you're going to the bathroom, dude?
Yeah. Oh yeah.
Okay,
I heard you the whole time. I was in the restroom now.
Okay, no problem. I will mark you here then.
All right. Thank you.
Oh, did I stress you out?
Yeah. I was like trying to hurry up.
All right, man. I'm sorry about that.
It's
But
all
I
right,
got
thank
you here. You're good.
All right. Bye.
Okay, see ya.
Mr. Sanchez.
Okay, let me check your. I know you're asking about your assignments, right?
Yeah.
Okay. I'm gonna fix that right now.
Uh-huh.
Do you want to wait, or just want me to fix it and then ask me tomorrow?
I'll fix it and check. Because I don't have my phone right now. So I'm kind of just like, I have to do everything on the computer. So it's like kind of everywhere with me right now.
What do you mean you don't have your phone right now?
I
Like,
don't.
You
I
you
gotta-
should be on your computer, not your phone.
No, I know, but like usually that's how I do that's how I would do the assignments. And like it's easier to check on my phone because it's all right there instead of the computer.
All right. But yeah, but oh, I see to check. Okay. I am fixing it right now, and then it should be done by tomorrow. I'm gonna check on all of them, okay? Jasmine.
Thank you.
All right. I'm sorry about that, but I hopefully we can fix the problem
okay.
about, you know what I mean, like getting it.
Yeah.
All right, but I will see you.
Okay.
Okay, take
Bye.
care. See you tomorrow.
All right. Bye.
Okay, bye.